The first step the user must follow is to model any self-supporting triangular structure on the tower analyzing software. Also, the Lisp program called Tower Schematics Prototype must be installed in the computer, along with the other installations files. Once these previous steps are done, open the tower file and model all its parameters. Configure all the code parameters you will be using on the tower. The user can configure every one of them in the Options tab. The next important step is to set the tower geometry. Configure every parameter that requires to do so. You can add legs, diagonals, horizontals and redundant members. Hips and inners bracings are also supported. The only limitation is that it must be a triangular self-supporting tower. After the Geometry tab configuration, the next step is to set the Advanced, Dishes and Discrete Loads tabs parameters. The information on these tabs will be directly needed to run the program successfully. Some of this information will be able to be checked visually when the schematics are done, reducing the possibilities of input errors going unchecked. Copy all the tab information and paste it on the text archives with the corresponding name. Repeat the same procedure for the remaining tabs. Once the text files are full with the tabs information, copy the three of them and search the Autocad installation directory. This is the same directory where the schematics application files were installed. Once all the preparation steps are done, it is time to run the Lisp application. Export the Risa Tower file to AutoCAD's DXF, so it can be opened in the Program Leader. Open the AutoCAD file that was previously exported. This is the normal TowerCAD file that comes with the Risa Tower's tools. It shows the tower 3D model that was previously created in the analyzing software. It displays all the geometry and material information, but it is very limited for engineering schematics or project schematics that could show the information that is needed in the project's reports, like the dishes and discrete loads location and general information, or the legs union location. By using this application, the initial Risa Tower tool can be expanded to bring more utility and schematics work time reduction. To run the program, load the Lisp application and type Tower on the AutoCAD's command bar. Once this has been done, the schematics creation process will start. This will be done automatically. No user participation is required beyond this point. The duration of this process can vary between CPUs. Nonetheless, no more than 90 seconds should take it to finish. After the processing time has passed, the schematics are done. And the simpler model that the original software had is no longer needed. The first drawing to the left is the general tower schematic. It is a 2D model of the tower's face. It contains the horizontal members and sections elevations. It also contains the legs union location and the start and end points of tower sections, including their length. This schematic is also useful as a graphic display that can show input errors made previously on the Risa Tower software. Checking the tower parameters visually will make the process of fixing errors faster and easier. The material and size information will be considered for this program in the future. You can graphically check with this schematic if the union's location input was made correctly. As it can be seen, the schematic's elevation information match with the Risa Tower's input. The second tower schematic shows the existing equipment location, a function that the original software had, but couldn't be customized in Autocad. This schematics also reflects visually the corresponding azimuth angle of the existing elements. It also displays the most important information about the equipment installed. All this data can be verified in the schematic, making it easier to find if the input made in the analyzing software has any errors. Input errors are very common to newcomers. Checking the information on a schematic will optimize the process. As it can be seen, the dishes and discrete loads of schematics general information matches with the ones written in the analyzing software. You can locate any equipment on the information box by following its nomenclature. You can also customize the leader's annotation to improve the visual style's quality. The next schematic is very similar to the previous one. It is the same model of schematic, but this time is dedicated to the proposed equipment on the tower. It has the same information box corresponding to the new equipment's data. As it can be seen on this one too, the information on the box matches the one that was written on the Risa Tower input tab. And as it was on the previous schematic, this one displays the different proposed equipment on the tower, including visually, the azimuth angle orientation. The fourth schematic brings back the original 3D model exported from the analyzing software, separating the existing equipment from the proposed ones, like the two previous schematics. The Risa Tower Schematics application also models the equipment in 3D solids that can be renderized. This allows a superior graphic display that can show how the equipment will look on the real tower. This feature is also useful to check if the azimuth angles described in an existing tower's report were correct. The equipment supports are displayed scaled with the dimensions that were set on the analyzing software, including the lateral and horizontal offset variables. The last schematic offers the same 3D model described previously. only that it is the proposed equipment this time. By presenting the visual information this way, the user can get a better idea of the space that will be occupied by the equipment. The identification tags are also able to be customized in 3D.